Question number 11. The graph shows how the momentum of a motorcycle changes with time. So this is the graph given. What is the resultant force on the motorcycle? So by the second law of motion, the resultant force acting on our body is equal to the rate of change of momentum. So this is the formula. F is equal to delta P over delta T. Since the graph is given, to find out the gradient will give you the value of force. So here the delta P is equal to 5000 by the graph, and the time taken delta T is equal to 10 seconds. So you just need to substitute like 5000 divided by 10, so it's gonna be 500 Newton. So it is option A. Question number 12. A rocket has a weight of W and an initial acceleration of A as the rocket leaves the ground vertically. The acceleration of free fall is G. Which expression gives the initial upward force exerted on the rocket due to the engine? So what happens is that here, suppose there is a rocket, and the rocket definitely going to be having a weight downward direction, and initially there is an upward force. Let's represent it with the FU. So here you can find out that the resultant force will be equal to the upward force minus the weight, isn't it? So you can just rearrange this one for the upward force, and that's gonna be F plus W. Then the resultant force is MA plus W. So this is the formula, and you need the value to be of weight on both sides. So we can substitute for the weight, which is mg. There is no m present in any of the option. That's why we are substituting for the m using the formula for weight. So it's m is equal to w over g. So the equation goes to be like w over g a plus w. So the correct option is A. Question number 13. A uniform road of weight 28 Newton is supported at one end by force F. The rod is in equilibrium and attached to a frictionless hinge at end X. What is the magnitude of F? So here it is mentioned that it's a uniform rod, which means that the length, like the weight, will be acting at the middle. So let's split the uniform rod into a length of 2L. So at the middle to the X, it will be of a length L. So you can find out the, you can use the formula for the principle of moment. So it means that it's given that the rod is in equilibrium. So if an object is in equilibrium, the sum of clockwise moments about any point provided by the forces acting on the object is equal to the sum of the anti-moments about the same point. So we can choose a point, and that point is about the pivot X. So about this one, the clockwise moment is by the 28 Newton and anti-clockwise is by the F. So let's find out the moment for the clockwise one. So always the moment of force is the force value multiplied by the perpendicular distance from the pivot. So the perpendicular distance is this. So that's gonna be D, and that is equal to F multiplied by the perpendicular distance between them is 2L. So you need to substitute for D. So that's why we are taking the triangle like this. So we are taking this triangle. So this triangle has this length D and this angle to be 40 degree and this length to be L. So you can choose cos 40, and that's gonna be adjacent side divided by the hypotenuse. So you can substitute D as L cos 40. So here you can substitute 28. L cos 40 is equal to F2L. So L and L get cancelled. So F is gonna be 28 cos 40 divided by 2. and that value is 10.7 Newton, so it's nearly equal to 11 Newton. So the option is B. Next question. Two forces, each of magnitude F, act in opposite directions on a road. So this is the picture. Each force acts on the road at a distance d from the pivot P. What is the torque of this couple about P? So always the torque formula is force multiplied by, say, any one of the force multiplied by the perpendicular distance between the two forces. So the couple, so these two forces acting at a different points, like same and equivalent forces, but in the opposite directions, represent a couple of force, and this couple of force is what makes the torque. So to find out the torque, multiply any of the force, like at one of the force, and the distance between the two forces, and that's gonna be 2t. So 2t. So here F multiplied by 2t is option C. Question number 15. A man of weight 600 Newton stands with both feet flat on the ground. What is a reasonable estimate of pressure exerted on the ground by the weight of the man? So the pressure formula is this: normal force divided by cross-sectional area. So P is equal to force divided by area, and the force here is gonna be the weight of the person divided by the area. So weight is already given, and the area of the 2 feet, when you have made it really closer, so it's gonna be around here 25. The length is, like, for an average person's 25 centimeter, and for this distance is gonna be, let's take it as 15 meter. So the area is gonna be 25 times 15, and that is 375 centimeters square, or in meters square it's gonna be 0.0375 meters square. So you can substitute over here with the values. So 600 divided by 0.0375, and it's gonna be 1.6 times 10 to the power of 4 Pascal. So the correct option is option C. Question number 16. The formula for the upthrust on a block of wood partially submerged in water is shown. F is equal to rho GV. What do the symbols rho and V represents? So for this formula, the rho represents the density, V represents the volume of the fluid displaced, and G is the acceleration due to gravity. So density is the density of the water, so it will be either A or B. And here the V is volume of the whole block. It's not true because it's partially submerged. So here, if this is the water level and the block is submerged like this, only this volume is what we will be taking. So the volume below the surface of the water. So it's going to be option B. Question number 17. An object with a mass of 100 grams falls a vertical distance of 10 meters. What is the change in the gravitational potential energy of the object? So the formula for the gravitational potential energy is like this: mgh. So the m is given as 100 grams, so we can convert into kilograms, which is 0.1, and multiply with the g value, which is 9.81 multiplied by 10. So it's gonna be 9.81, so nearly 10 joules. So option B. Question number 18. A bungee jumper jumps from a platform and is decelerated by an elastic bungee cord as shown. When the jumper makes the jump, his initial gravitational potential energy related to the ground is converted into his kinetic energy and into elastic potential energy in the cord. At which part of the jump are all three types of energy non-zero? So here for the first option, on the platform before the jump. So before the jump, it will be having only the potential energy, not the kinetic energy. So only potential energy. For the second option, on the way down, before the core has started to extend. So on the way down, the potential energy will be decreasing and the kinetic energy will be increasing. But elastic energy will be zero. Okay, so there is no the third type of energy present. For the option C, on the way down as he decelerate. So here the potential energy, so you can see it is at a particular distance, so definitely there is a potential energy. And kinetic energy, it's having a change in the speed, right? That's why it is decelerating. So kinetic energy is present. Then since it is decelerating by an elastic bungee jump, it will be having a elastic potential energy as well. So it will be option C. So if you want, you can check the last option, and at the bottom of the jump when he's stationary. So it's clear that kinetic energy is zero at the point. Question number 19. A sailboat is pushed by the wind at a constant velocity v across a lake. The force of the wind and the velocity of the boat are in the same direction. Which additional information is required to determine the work done per unit time by the wind acting on the sailboat? So you know, the work done divided by time is what we call the power. So work done you can split as force multiplied by the distance over time, and the distance over time is what we call the speed or the velocity. Okay, so here for finding the power value, you just need or the work done per divided value is equal to force multiplied by the velocity, and out of this you already have the velocity value, then what you need is the force value. Question number 20. A spring is fixed at one end. The length L of the spring is increased by applying a tensile force F to the other end. The graph shows the variation of L with F. What is the elastic potential energy of the spring when F is equal to 6 Newton? So the formula for the elastic potential energy are these. So here, since the F and L is given, you can go for the formula E is equal to half F delta S. So here you have the value given for the force. It should be 6 Newton, and at the 6 Newton, how much will be the extension? So that delta X or the delta L as per the representation is gonna be 12 minus 8. That's the extension. So 12 minus 8 is gonna be substituted here. So it is in centimeter. So it should be converted into meters. So 10 to the power of negative 2, and the value is 0.12 joules. So the correct option is A.